You studied for months. You read every piece of documentation and memorized every AWS service name. But you sit down for the exam, read the first question, and your stomach completely drops. You have no idea what the answer is. This happens because standard study guides treat AWS like a dictionary, but the exam presents you with a system in crisis, a specific error code, a timed-out request, or a backend that's currently melting down. AWS doesn't care if you can recite the definition of an SQSQ. When you view the questions through that lens, you realize they aren't vocabulary tests at all. Instead, they are actually hidden system failure patterns. Every scenario on that screen contains a specific bottleneck, a sudden failure, or a hard operational constraint waiting to be triggered. Shifting your mindset from memorizing services to predicting where these systems will break is how you reverse engineer the test. Once you identify the failure, the answer becomes predictable. Think about a suspension bridge. You calculate exactly which cable snaps when a hurricane hits. In the cloud, you must instantly identify the underlying framework to find the breaking point. Is it a synchronous API, an asynchronous job, or an event-driven workflow? Take this scenario. A massive Black Friday traffic spike causes an e-commerce checkout API to drop requests because the backend database is locked. You might be tempted to write complex multi-threading code or buy a massive database server. But AWS rewards resilient architectures, not clever code. The solution is to drop an Amazon SQSQ between the components. The queue absorbs the spike and buffers the load, allowing the database to process orders at its own pace. If a multiple-choice option requires you to write custom retry logic, build a proprietary caching layer, or manually provision servers, it is likely a trap. AWS is testing your ability to choose native decoupled patterns over custom workarounds. AWS uses the exact same failure patterns repeatedly. Spot them early and you can find the correct answer before you finish reading the prompt. Pattern 1. Duplicate requests. A network router blips and an API call is sent twice. If the system isn't prepared, you've just charged a customer's credit card twice. When you see duplicate transactions, the answer is always idempotency. By requiring a unique client token, the function recognizes the duplicate and rejects the second packet before it can process the same order again. Pattern 2. Slow distributed systems. Your individual microservices are healthy, but the user experience is lagging. Don't pick CloudWatch logs. You need AWS X-Ray. You trace the request through the architecture to find the specific API dragging the system down. Recognizing these patterns shifts your focus from guessing between 4 options to identifying the structural flaw causing the delay or the duplication. Pattern 3. Database performance. A DynamoDB table is suddenly consuming thousands of read capacity units and timing out. This usually points to a scan operation instead of a query, or a query hitting DynamoDB's strict 1 megabyte hard limit per network request. The resilient solution is to implement programmatic pagination using the last evaluated key. This fragments the data into smaller, manageable blocks that pass through the gateway sequentially. Pattern 4. Serverless execution. A Lambda function works on your machine but times out in the cloud. This often happens because it was attached to a private VPC without a NAT gateway, cutting off its internet access, or it has a massive dependency causing a cold start. The almost correct trap is to simply increase the timeout limit to 15 minutes. The resilient answer is to allocate more memory to provide a faster CPU or move initialization code outside the handler. Finally, remember least privilege. If an EC2 instance needs to read from S3, you never embed access keys, you attach an IAM role. These technical traps, from DynamoDB limits to Lambda cold starts, are testing your ability to protect a system's operational boundaries under pressure. This is the core of the Developer Associate exam. AWS isn't asking what a service does, they are asking how that service behaves when it is pushed to the limit. First, look past the service definitions to find the hidden failure pattern in the question. Second, identify the architecture pattern so you can predict the failure point before the traffic spike occurs. Third, avoid options that rely on custom code. Choose native AWS patterns like SQS for decoupling and idempotency for safe retries. Passing the exam isn't about memorizing the dictionary. It's about understanding how cloud systems behave and break. When you stop studying flashcards and start studying patterns, the answers reveal themselves.